Hello dear students, so this is chapter number 4, and in chapter number 4 we have to analyze different type of circuits which contains one or two sources. So this is assessment problem 4.1, in which we are asked to find the value of this V1, I1 and V2. Similarly, in part B of this question we are asked to find the value of the power which is supplied by the 15 ampere source, and then after it we have to find the power which is provided or supplied by this 5 ampere source. So we have to apply the node voltage method. So what is basically a node voltage method? In node voltage method we have to identify different types of nodes in a circuit, and then we have to select one of those nodes as a reference node. After it we have to apply KCL over each node, and analyzing an analysis by using the KCL will eventually give us the required values. So here the first step is to identify our node. So node is basically a point where the voltages remain same. So here we have different nodes. So first of all, identify those nodes. So this is basically our first node, this is the second node, okay, this is our first node, this is the second node, and this one, the last one, in which all the other are connected, this is our third node. Okay, so these are basically our three nodes. So what will be the procedure? Here we have to select one of these three as a reference node. Which one of them we have to select as a reference node? So in many questions, the node where most of the branches are connected is selected as a reference node. So here we have this, we will select this 3 as a reference node. So by selecting 3 as a reference node, and then by analyzing the circuit, we can convert this one into an equivalent circuit, which will be like, let me draw it here. Our equivalent circuit will be like this one, that here we have V1 and here we have this V2. So these are basically our two voltages which are across this 5 ohm resistor. Okay, so here we have one branch which is this one. Okay, so this is of 2 ohm, they call it 2 ohm, and the other branch at this V2 is this 5 ampere source. So let me draw it here again as this one. This is the 5 ampere source. Okay, these are the two branches which are connected with this node 2. We call the voltage at this one, node 2, as V2. Okay, so now let us consider this node 1. At node 1 we have 3 branches. The first branch here basically have this resistor which is of 15 ohm. The other branch here, this has 60 ohm resistor, and the third here is source which is of 15 amperes. Okay, so now here we have this equivalent circuit which is derived from this circuit. So we can easily see that here we have 3 nodes, this one, and this one. Let me call this node as a reference node. Okay, so this is our reference node, and all these two are basically the nodes across which we have to apply the KCL. Okay, so let us considering the first node, which is V1, and here at V1 we have basically 3 currents which are going away from this node. So these are basically the I1, I2, I3 and I4. Okay, so these are basically 4 currents which are going away from this node 1, which are I1, I2, I3, and this one is the I4. Okay, it is moving from V1 to V2. So considering V1 here, let me do all of this calculation for V1 in red color. So for V1, I1 plus I2 plus I3 plus I4. This is equal to 0. How is it equal to 0? This is by the application of KCL. Okay, so according to KCL, the sum of all the currents which are flowing away from a node is equal to 0. So what will be the value of I1? We know that the direction of I1 is going away from V1, but here we have the current source already available, which direction has opposite of this I1. So let me write it as minus 15. Okay, what is the value of I2? Applying the KVL here, we will see that the value will be equal to the potential difference divided by the resistance. So the potential difference here is basically V1 minus 0 divided by 60. This is the potential difference divided by resistance is equal to I2. Similarly, the potential difference here at the third branch is basically V1 minus 0 divided by 15 plus I4 is equal to, again, the potential difference. Now the potential difference is with respect to the V1 minus V2 divided by 5, and this is equal to 0. So let me move this minus 15 at the other side. So when I will move it at the other side, I will have, by simplifying the other equations, V1 by 60 plus V1 by 15 plus V1 minus V2 divided by 5. This is equal to the 15. Okay, so now for solving this equation, we have to take the LCM of the three terms, which are 16, 15 and 5, and after finding the LCM of this is equal to 60. Okay, the LCM of this is basically equal to 60. So multiplying it, we will have V1 plus, this is multiplying V1 by 15 by 60, we will have 4V1, and here we will have 12V1 minus 12V2. This is equal to the 15. Okay, so by again we have to simplify it. By simplifying it, I will get 17V1 minus 12V2 is equal to, moving this 60 at the other side, we will have 15 multiplied by 60. So the equation we will have, the ultimate equation will be 17V1 minus 12V2, and this 60 multiplied by 15 is 900. Okay, so let me call it equation A. Okay, so this is equation number A, which is obtained at V1. Okay, so let me separate it out. So this is all the calculation with respect to this node, which is at V1. So let me write it in red as well. Okay, so at the other side we have this V2. So for V2, let me select a green color. So this is V2, and here we have more currents which are flowing away from this node, and these currents are basically, this is the current, let me call it I5, this is I6, and this is the third current, which is I7. Okay, so now this is in green color. Let me solve it here. So here at V2, by applying KCL, we see that the values are I5 plus I6 plus I7. This is equal to 0. Okay, let me write their values. Let me write their values. So I5 is again equal to the potential difference divided by the resistance. So the potential difference here is V2 minus V1 divided by the value of the resistance, which is the 5 ohm. The value of I6, again V2 minus 0 divided by 2, and the value of I7 is given here, which is basically 5 ampere is of source. So this is equal to the 5 ampere 0. Okay, so again, so this is our equation here. So in order to simplify it, let me take the LCM here. So the LCM here will be 10. So 5, this multiplied by 10, this will be equal to 2v2 minus 2v1, okay, minus 5v2, and moving it at the other side we will have minus 5. Okay, so simplifying it, by simplifying it and adding the corresponding values of v1 and v2, we will have minus 2v1, okay, minus minus 2v1 plus, this is minus v2 minus 5v2, sorry, this is plus, it was my bad, this plus 5v2 plus 5v2 plus 2v2 is equal to plus 7v2, and this is equal to minus 5 multiplied by 10. So ultimately we will have the equation which will be 2v1 plus 7v2 equal to minus 50. So this is equation B. So now we have two equations which are in terms of v1 and v2. So now we have two equations and two unknown. We can solve these equations by any method which you like. So I have chosen to use the matrix method. First of all, I have to convert it in the form of a matrix and then solving it. So in order to convert them into the matrix form, a matrix here will have 17 minus 2 minus 2 and 7, this one here. Similarly, v1 v2 is equal to 900 and minus 50. So now this is our system of linear equations. We can solve it by any method, whatever we like. So this is our matrix A, this is our matrix X, and this is Y. So it is basically the Y is equal to AX system of linear equations. So in order to find different values of v1, we are going to use the Crammers rule. Okay, in Crammers rule, first we have to replace the first column of our fat matrix A with this Y. This is a column matrix, so writing the this is the determinant basically. Okay, so this is 900 minus 5, and similarly the other column will remain same, this is 7, and taking the determinant and then dividing the overall over the determinant of this A fat matrix. So the fat matrix is basically 17 minus 2 and 7, and the determinant of this matrix. So after finding all the values here and finding the determinant which is at your side, we have found out that the value of v1 is 60 volts. Okay, similarly we had find out the value of v2. In v2 we have to replace the second column of our fat matrix A with this column matrix Y. So we replaced it, and by replacing it we got 17 minus 2 900 minus 5 divided by the determinant of A, that is 17 minus 2 7. Okay, so after doing all the steps, we find out by this Crammers rule that the value of v2 is 10 volts. So these are basically the values which we had to find out. Okay, so this, what is v1 and what is v2, these are the values at node. v1 is here, v2 is here. These are the values which are v1 and v2 here as well. So the same value which is appearing here is here, and here as well. So the v1, small v1, is basically equal to this small v1 is equal to v1. Similarly, this v2, which is which is here the same, because we know that at each node the value of voltages will remain the same, so the value of small v2 is equal to the capital V2, so the values remain same. Now in order to find the value of this current, which is I1, we have to use the formula which we have earlier used with this one. Okay, the potential difference divided by the resistance is equal to the current which was here as well. I4 was the current which was flowing from V1 to V2. So let me go down here. Okay, so the value of I1 is equal to V1 minus V2 divided by 5. So the value of I1 is 60 minus 10 divided by 5, so ultimately we will get 10 amps. Okay, so this is the 10 ampere current which we had to find out. Okay, so this is the solution of part A. In order to find the solution of part B and part C, we know that how much power is delivered to the circuit by the 15 ampere source. So this is the 15 ampere source, the current is already given. In order to find the power it delivers, we have to find out the voltage across this one, which is also given, which we have also find out, which was V1. So the power supplied by this one is equal to PIV. Similarly, the power supplied by the 5 ampere source is also P is equal to IV. So now let me do it. Let me go down. So the power supplied by the 15 ampere source is equal to I into V1. So I is 15 multiplied by the V1 was 60. So this was equal to the 900 watts. Okay, so this was equal to the 900 watts. Yes, it was a 900. Similarly, in order to find the value of this was B, in order to find here, so this is I5 multiplied by the V2. Now the current the direction of the current here is at the opposite direction, so minus 5 multiplied by this is minus 50 watts. Okay, so these are basically the two values which we had to find out. This one 15 multiplied by V1 and 5 multiplied by V2. This is the overall thing which we have to find out. So this is the question. In this question we have seen that how to analyze any circuit by using the node voltage method. First of all, we converted the circuit into a very simplified circuit, and after analyzing that simplified circuit, we saw that other quantities can be find out very easily. So thank you so much, and I will see you in the next lecture.